In today's class and video, we are going to look at how to quantify protein concentration using the UV absorption method. We'll start our introduction by looking at why proteins absorb UV light at 280 nanometers. So first of all, the concentration of proteins in a solution can be determined by measuring the absorbance of UV light at 280 nanometers. What we have to note is that this method is based on the fact that most proteins absorb UV light in proportion to their concentration at 280 nanometer, and primarily this is due to the presence of tyrosine and tryptophan, and to a much reduced extent phenylalanine and cysteine. And since the tyrosine and to a lesser extent tryptophan content of various proteins varies only within reasonable limits, the absorption peak at 280 nanometer is used as a rapid and very sensitive measure of protein concentrations. And also, this method is also known as absorption at 280 and normally written like this, and it's often used to roughly estimate protein concentrations, such as to check if a purification process was successful. And it's a popular method for purified proteins because it's fast, convenient, and does not require additional reagents or incubation. So now let's look at some limitations to this method. So the first has to do with protein mixtures. And what we have to note here is that different proteins have different aromatic amino acid contents, which can vary their absorption characteristics. So the next limitation has to do with non-protein content. And what you also have to note here is that any non-protein content that can absorb UV light can interfere with the measurement. Example, nucleic acid, which are apt to be present in some protein preparations, have a strong UV absorption band centered at 260 nanometer, and as a result can interfere with this assay. So the next limitation has to do with protein sequence, and this method is only applicable to proteins that contain tryptophan or tyrosine residues. And if the protein sample doesn't contain tryptophan or tyrosine, the scoped method can be used to determine the concentration by measuring the absorption at 205 nanometer. So now let us begin to look at our test protocols, and we will start by looking at the materials needed for this experiment. So the first has to do with our standard protein, which is 10 milligrams per ml BSA, our unknown protein samples or protein solution, and a spectrophotometer with wavelength at 280 nanometer. So test method. So the first is to dilute your test sample with the right dilution of your choice. So you can do 1 in 5 or 1 in 10 or 1 in 100 dilution depending on your choice. So 2 is to measure the absorbance at 280 nanometer against a blank with the spectrophotometer, and normally the blank should be your diluent. Example, distilled water. So what it means is that in diluting your test sample, if you should use distilled water to do the dilution, that means you obviously use distilled water as your blank. And the next step is to determine the protein concentration of the unknown protein solution from the calibration curve. So what it means is that we are expected to plot a calibration curve. Now let's see how to estimate the amount of protein in our test sample using the calibration curve. So you first have to prepare a calibration curve from the known concentration 0.0 milligrams per ml, 2.0, 4.0, 6.0, 8.0, and 10.0 milligrams per ml. And these concentrations are being prepared from the standard BSA with a concentration of 10 milligrams per ml. So we will prepare these various concentrations from the standard using the equation C1V1 equals C2V2. So when we are done with that, we plot the absorbance obtained for each of the concentration at 280 nanometer against the known concentration. So if you should look at this is our calibration curve, and we had this calibration curve by plotting the absorbances obtained at 280 nanometer from these known proteins over here. So on the x-axis, we can see that the concentrations of the known proteins are here, and that of their absorbances are represented or is seen on the y-axis. So once we are done plotting the calibration curve, we determine the equation of the line and use it to determine the amount of protein present in the test sample. So from this calibration curve, we can see that the equation of the line is giving us y equals 0.9972. So where y happens to be the absorbance values on the y-axis, the 0.9972 happens to be our slope or the gradient of the calibration curve, and the s happens to be the known concentrations on the x-axis. So if you want to determine the concentration or the protein concentration of our known or of our test sample, what we have to do is that we only make s the subject from this equation and place in the value for the absorbance of our test sample to determine the concentration. So let's assume that when we did our test analysis and measured, we had an absorbance value of say 8.5. So what it means here is that in place of the y, we put here 8.5 and divide it by the 0.9972 over here to be able to obtain the s value, which represent the amount of protein concentration in the test sample. So when you are done, one important thing that we have to note is that it is important to multiply the obtained protein value with the dilution factor of the dilution you did. Thank you.